Hari Om. In this small video, we discuss the energy stored in an inductor. An inductor is an instrument, a coiled wire closely wound that produces the effect of inductance. So an inductor can be shown like this. Now this inductor is connected to a battery here, a cell here, and a switch. What is the energy stored in the inductor means? It can be treated as the work done by the external agency to set up a maximum current I0 through this coil. Work done in setting up a current of I0 by the cell connected here is called the energy stored. And this work done, why this has to do work? Because as the current starts flowing through this inductor, due to the inductive effect, there is a back EMF is produced by the inductor. This back EMF will be opposing the current flowing through the coil because of the Lenz's effect. And therefore, this cell has to force the current through this coil against the back EMF. That is how the work is being done here. So that's the amount of work done by the external agency is getting stored in the inductor as its magnetic energy in the coil. So how to find out the work done? Let us see. So initially there is a current 0 before switching on. The moment I switch it on, the current starts increasing from 0 to I0, the maximum. But at the instant, there is a current I flowing through this one. Due to that current flowing, there will be a back EMF produced, which is equal to L di by dt. So this cell has to do a work against this one. Therefore, the power set up by the supply will be equal to minus L into di by dt is the back EMF minus, because against that it is doing the work. Okay, into the current I. So power is equal to current into voltage. So this is the power developed there. And at the moment the work done, there will be a small work done dW. That dW is acting for a time dt second. That dt second time can be taken as power multiplied by the time dt. Therefore, the small work done dW will be equal to power, that is L into di by dt into the current I into dt plus 5. So this is small amount of work done during a time interval of dt seconds. And therefore, you can see that this dt and this dt cancels and you are left with dw, which is equal to L into I into di. Therefore, as the current goes on increasing from 0 to I0, this kind of small work done are coming, and all those work done you are getting added up, or you are adding it up to get the total work done. So the total work done in setting the current from 0 to I0 in the inductor or through the inductor by the supply will be equal to integral dW, which is equal to integral L into I into di from 0 to I0. Now inductance L is a constant for the given system, so you can take it outside, and I di varies from 0 to I0. So integrating this, you get L into integral 0 to I0 I into di, that's equal to half L I0 square. So this is the total amount of work done. That is W, which is equal to half L I0 square. So this is the amount of work done in setting up a current of I0, the maximum, through the inductor. And this work done is getting stored in this inductor as its magnetic energy. So magnetic energy stored, U will be equal to half L I0 square. So energy stored in the inductor, you are getting the equation as half into inductance into the maximum current flowing the square of that. Okay, so this always the supplier has to do an amount of work against the back EMF set up instantaneously, and that work done is getting stored in it as the what you call the potential energy or magnetic energy in it. And this energy is stored in this coil in the form of magnetic field. Okay, so please do remember the step. We are starting from power, and power to the small work done in small time dt second, and then